So back to programming. Now the fifth question. Read all lines from standard input and count all lines containing at least n a's, where n is a command line parameter. So again, we need command line parameters, right? Okay. So we need the first command line parameter and only the first. So the command line parameter count argc should not be different than 2. If argc is different than 2, then return -1. This is our problem now. You know, oh, -1, it's bad because we have wrong number of parameters. Set program's arguments. Let's set arguments to 3. So it's gonna pass and it's gonna return 0. Yeah. So now integer n as in a list equals a to I of argv of 1, the first argument. So we don't care if it's a string or whatever. You're responsible. The user is responsible for it. If we type like ABCD and this function processes it, it will be 0, and will be simply 0. Okay. So n a's from standard input and by lines. How do you do that, right? Look that I've preserved this. It might come handy. So just leave it be. Okay, so how do you get it? With functions like getS or safer fgetS. It takes pointer to character. It's a string where you're writing your lines. Integer is the size of the line, maximum size of data that it will fetch, and file. You are getting the data from standard input. So now define the line character line, and we want it to be like 500 characters will do, right? So now to get line, every single line from standard input, not only 1, not 3, not 4, every single line that user types until he presses this majestic Ctrl Z in the command prompt. You type while fgets line size of line, because character has the size of 1 byte, this will be exactly 500. It should actually be -1 because we want to have room for a null character. But god damn it, wow, we live once, right? We could actually ignore it. So now we couldn't. Now, because if we use like string length, it will count 500 and something more if we take exactly 500 characters, because there's like the line in the file has 7,000 characters. We only get 500. There's no null character at the end, and the string length would return something, you know, that we haven't prepared for. So, and then we get from std in. It's not in any library, it's just a constant, std in, you know, defined there somewhere. And it will return something not null if the end of line hasn't been reached. So fgets returns null if it's at the end of data and, you know, it doesn't have anything more to do. So let's type, you know, and we get every single line, and then Ctrl Z, and it ends the program. That's it. So, you know, basic core of the program that takes every line from standard input, and then read all lines from standard input and count all lines, whatever later, containing at least n a's. So we have to know how many a's are in the line. So what we do? Yeah, we write another function, and car number in string, because I like it. You know, str, because str is used widely. Car, the first parameter is of course pointer to the character, so a string, and then a character, single character, because you know that's what we do. the previous videos uploading right now. And so to do it, to actually find the number, we need integer result. Some number that we will iterate. We assume that there's 0 at the beginning because we haven't checked anything. And then we use loop that takes us everywhere for every character in a string. This one, exactly. That's why I like naming my variables the same. Of course, we can define I now. Without initialization, it's here. So that's the loop. What do? We increment the result every time we encounter character CHR. So if str of I is equal to CHR, then what? Result plus. For every character in a string, we just look at the character and compare it to this, and if it's CHR, we increment this variable, and then return it. Look that if it's not found, 0 will be returned, like it should have been. Okay, return result. That's our function. You would think that it's very complex or something like that, but it's not. You see, it's not complex at all. I can even shorten it more because I love it. I love short functions. And that's it. Very useful function. Very useful. And quite fast too with small strings. So, yeah, we count all lines where there's more, at least an ace. So, if, how did we name it? Car number in string argv of no argv, I'm sorry, line, the line that we just fetched, and character is simply a. Look that we are doing this like that. Actually, C understands this a as its ASCII code. Actually, some different code, but it's compatible with ASCII, so it's 96 or something like that. But yeah, something like that. But it has to be in those single quotations. Character number in string, line A, has to be at least n, greater than or equal. And now we have to not print those lines, although we could, like puts line, if this condition is met. So let's check it, n is 3. So we have to have 3 A's, so the program will repeat what we typed. Oh, there's not enough. There's no A's. There's no A's because it's case sensitive. Automatically, ASDF, 3 A's, and it repeats after us. It's good. A. It repeats. A, not enough. That's working. And we have to count them. So another integer that will give us a result. Equals 0, of course, and we just increment this. Result plus. Puts, now printf. We will format the output nicely. Okay, so what do we write? The number of lines containing at least %d A's was %d, and the first parameter is n, and then it's fuck you, and then it's what? Result. And result, the number of at least. So yeah, let's run it. Those lines do not matter, it's uppercase A. 1, 2, 3, 4, 5, 6. The number of lines containing at least 3 A's was 6. That is working. You know, I'm gonna show you something. I should have increased the font size, but I've seen yesterday the videos are pretty high quality, so I'm not gonna do it. Okay, presenter to continue. I'm gonna show you something. I'm gonna rebuild this. Yes, rebuild the entire project, and we've got the X output somewhere on the hard drive. And it will be in practical, and then in what was the folder? Jesus. Programs. Okay, CD debug, CD binary, CD debug, and now we have something here. It's our application, programs.exe. So we will copy Nostromo in this directory. Copy C practical Nostromo, copy it here. Okay, we have Nostromo here. Type Nostromo, so pipelining it in. You know, having fun with your programs, your own programs. Programs X, and we want the lines that contain at least 12 A's. One line only in the whole Nostromo file, containing at least one A's. 15,718. And then like no A's at all. The number of lines in a Nostromo. That's it. You see? So you can have fun with your own programs. You can check if they work. You can be proud of your just creating. And frankly, you know, I could be writing some bigger programs, but these small things are actually very funny to write. So you see, this is very simple and very short, and actually it's thanks to the function that we've just written. It's just one line again, and it could be 4, and this would just look like a whole sprawl of code. You don't want that. Okay, so the next one prints out the most frequent characters from the standard input. That's funny. Okay, the most frequent characters. I want this. Okay, the most frequent. Okay, I've got a call. Yeah, I can't pause the video, so I'm gonna stop it here, okay? Okay, so let's get back to it. As was said, we have to print out the most frequent character, S, from the standard input. I don't know how many. That's the problem. How many characters? What do you mean frequent character or characters? I don't know. But to show you the basics of this task, you need a way to store the number of occurrences of the characters. Actually, it was covered by some assignment list on labs, but I'm gonna write it right here. And occurrences, and it's gonna be an array of 256 values. 256 because the characters that are printable in the command prompt. Therefore, in this application, there is only 256 of them. Actually, we will be able to get inside this why it is so. And yeah, okay, I'm gonna show you something later. But we need this array to be zeroed. And we could do it like writing a loop here that assigns 0 to every integer, but a compiler can do it for us with something like that. We only assign one value to 256 values, and it does it for every other value. You know, it's like we would have to type something like that, 256 zeros, but this would do, and only 1 0 does also. So 1 would be everywhere in the array, but we want 0, as the initial value of occurrences is 0. So to get the count from standard input, so we have to get single characters from standard input. You know how to get lines, but how to get characters. We define character like that, and then while while loop, because there's a condition. The condition is that the data was read by the program. So while get character, and get character does not take any parameters, and it returns integer. It's actually character, but whatever, something like that. So it returns. So character equals get char, and to check whether the data was read successfully, we have to test this character. The character will be simply the end of file character, because end of file is also a character. That's funny, and we put that in parentheses and check whether it wasn't the end of file character. If it was, we have to break the loop, and now this program will basically wait for characters. For every character it does something, nothing in this case, and then it ends. So this is the way you do it. Then we have to do something, we have to count the occurrences of those characters. So basically, if you write something like that, outside the loop maybe, occurrences like of A, it's actually occurrences of maybe 96, I don't remember. Well, we will need, the first part has been uploaded already, so that's nice. And yeah, let's get it. I've had it like in dashboard. I remember it. I remember having it. Yeah, simple client. No, probably not this. Manual, not ASCII table. Yeah, that's exactly what I wanted. Here, it's uppercase A, has the code 65, 97. So I was pretty close. It has a code of 97. You see 0 through 127 characters in ASCII. And there's more, there's more. But let's actually have that. Oh, it's snowing right now. Let's leave it here. Okay? So you see that every character has its number above it. It's 91 for this one. It's 73 for this one. So actually writing something like that is actually the same as writing something like that. It's the same. And occurrences of 97 is now equal to 0, but we can make it equal to this number, and it would be valid, and it would mean that A or 97 character with the number 97 occurred this number of times. So while and then let's simply do something like that. Occurrences of the current character that we are operating with. Incremented. Do something like that. And this counts the occurrences of every character. Of every character that we can type. 256 characters are possible in Windows command line. And the first 127 are these. Exactly these. So you can see null character is here. 0, it's /0. There's no end of file here. Well, end of transmission, it's not end of file. End of file has a different code. End of file is actually -1. So, yeah. Let's get it done. So we counted the occurrences with that simple loop. Now we have to display the most frequent characters. I don't know how many. This is not set. I'm gonna do it with the simpler thing. I'm gonna do it like that. 4, and then I need, of course, integer value, int I. I equals 0, and then we're gonna I less than or equal to 950, 55, 56, because counting from 0, and I plus plus, and then we're just gonna print f, and then we're gonna print fuck you. Okay, that's a beast. We're gonna print something like that character first, so %c, no, way to go, and then let's say a %d, and then it's gonna be I, and because I is an integer but it can be transformed to character, and then occurrences of I, and this is it. You see, this little loop will go through every entry in this. This will do some weird stuff, I promise you. You might ask why. Yeah, let's do something like that. Some characters here. And then, oh, there was a beep. I haven't included the new line, but what was the beep, you may ask? Well, it was one special character. The characters in the command line are used not only for printing some characters, Look at those. We don't need them. You cannot type them with keyboard. They can appear in the file, but pi, Greek alphabet here. The integral symbol. Quite a lot of stuff is going on here. The letters are here. And you see, D occurred 2 times, G occurred 1 time. But we don't want those symbols, right? We don't want this, or this. You can't say it. This one is actually, the first one. 0 character is null. It cannot be printed because it's null character. Then 1, 2, 3, 4, 5, 6, 7th character. And it's not compatible with this tab because you see, the code 7 actually goes to Bell. And this character is already compatible. Bell made that ding noise, this beep. Bell is responsible for that. See that there is one character that occurred. What was that character? This character probably was null. I don't know why it's also like that, but whatever. We are not gonna analyze this out, but it's funny. We could print the codes and we would see it, then print this character tab somewhere on the internet, whatever. But we are just interested in the characters from, let's see, from what? From 33, because this is space. We are interested in space. We have to print whether space was in the input because we can put it with our keyboard. It's pretty normal. 32, actually 126, because we cannot put delete in file, right? So 32 to 126. Let's do it. Initial value 32, 1, 2, 6, and we only print the characters that we are interested in. Look, 1 R, S, T, and there is no beep. 7 G's. That's a lot. And the first one is space. That's how you do it. That's how you do it. So, okay, that's one way to do it, but it prints all of them. Let's print the most common characters. Most common. Let's say that the most common characters are the characters that occurred once or more. If occurrences of I character, we are at 32 and we want to check the occurrences of space. We're not 0. Simple. And run. Only the characters that appeared. 1, 4, 2, 6, 4, 7, only the ones that appeared. That's one way to solve it. We can solve it in a bit different manner by getting the most common character and printing it, and we will then print like n most common characters. We can do it. We can print n most common characters. We need a function to do that. And get most common without parameters because everything is here. So, get most common character. The most common character will be simply fetched from every character. Okay, I'm gonna write integer I for I equals 0, I less than or 256, I plus plus for every character. I don't care whether it's printable or not. I'm checking if it occurred, right? That's a better way to do it. Okay, that's returning home. Choice. Yeah, so count, let's call it count. And then count will be 0. And if we find character that occurs more than count times occurrences I are greater than count, then count equals I. You see why? Because if we find something that occurred more than 0 times, we say that it's the ith character that we're at. Let's say it's A, and A occurred 2 times, and then count is equal to 97, and then we get B that occurred 200 times, and the count will be then equal to 98, because I is now 98, we are at B. So that's it. We get most common character. Now we also need something. So integer n most common characters. It's equal to a to I of the second argument. Argv, that's the stuff that we've been writing before. 1. Okay. If we want n most common characters, we can use while n is not equal to 0, and yeah, we have to decrease n every time we are printing out the most common character, and then print f. No, that's not a good loop. Sorry. Int I for, and now you see I equal to 1. I is less than or equal n I plus plus. Because if user types 0 most common characters, he doesn't want any character, right? Right? So if user types 1, basically user is counting from 1. 1 is 1, right? Not like in arrays or stuff. So int I am whatever you get. So we want to printf the most common character. The %d most common character was, and then %c here. So the ith most common character was, what was it? How did I call it? Get most common. Get most common. And then, so we know that it doesn't get chosen again as the most common character. We simply set its occurrences to 0, right? So occurrences of get most common equals 0. Because this is the same as this. We haven't done anything, it's still most common character. And here it's least common. And that should work perfectly fine. If it compiles. It is? Oh, it is compiling. So let's write something. ASDF, AS, and A. The foremost common character was, what the hell happened? What's the argument? 3. Okay, I totally don't know what happened. Get most common character. Let's only get most common character. Okay? Let's do it here. The most common character was, and this one, this thing is irrelevant for now, because I'm totally like out of the rhythm right now. Someone interrupted me. Something like that. The most common character was and nothing. See, there's nothing returned. Oh god, this function doesn't return anything. You see, that's what I've done. Return count. Count. It's not a good name. Yes, it's not a good name at all. Because yeah, we should rename it to best. And then you see, I'm doing a stupid mistake. Occurrences of best. Then best equals I. And we return best. And that should work. The most common character was D. Is that okay? I don't know, I'm not checking. ASD, ASA. For most common character. Why 4? I is equal 1. Then I is going to n. And we iterate I. Let's make some counts to fucking 3 because counts to n. Yeah, I feel ashamed. Oh, now I'm losing semicolons. Whatever. 4, it's only 4. Something is wrong. We should actually iterate. For one going to. Oh, there's a semicolon. I'm sorry for that. You see? That's how you make mistakes that you can't even. You don't even know what happens. Because I've put semicolon, this code was executed after the for loop. This doesn't do anything with those values. That's and we have to do it like that. Because we can't equal 1. And now it should be good, okay? SDF, ASD, ASA. First most common character was nothing. Again, nothing. It's new line character. You see? New line was most common character. Then it was A 4 times occurred. And actually maybe it should be like this. It's very common to say. SDF, ASD, ASA. The third most common character, again not printing the new line. You see, there's new line, there's not. The third most common character was S. It's correct, isn't it? But this would be nice to have. Yeah, definitely it would. So let's type something like that's like a sentence, the quick brown fox jumped over the lazy dog. Again, it was space this time. Then E. Then O. Let's Let's have some fun with it. Rebuild. I'm always rebuilding it when I want the X file. So command prompt. Let's go to Nostromo file. CD practical. Not this one. Oh. Programs and CD binary. CD debug, and then we type Nostromo. Oh, it doesn't feel commands. Yeah, type Nostromo. Then we call the program with argument of 6, the 6 most common characters. Of course, space. Then the second was E, the third was T, then it was O, then A, and then N. You see, we could actually write something like that. It appeared %d times. And one more thing here. Yeah. Occurrences of get most common. Something like this. And yeah, it's built. I don't care about it right now. No, not you. I've closed the command prompt. No, I did it. See, space appeared, wow, 155,333 times. E appeared 93,675 times. N appeared 50,629 times. Let's get 100 most common characters. And, you know, some weird stuff happens because we can't get these characters. There should be a condition that restricts it. Oh, 8 appeared 1 time alongside 6, 5, and 4. Their X appeared only 3 times. Z is interesting, only 4 times. Capital case Z is very long and yeah, so basically a whole alphabet. And then, you know, new line appeared 18,688 times. So maybe we should include a condition that, you know, ends this loop when we when the occurrences of this is occurrences. You know, I'm calling it so many times that I could assign it to variable if occurrences of get most common equal 0, break, and rebuild. Yes, it should now print something normal, you know, without any weird stuff. 75, then end of data. You know, it doesn't have anything to print. So yeah, that's been some fun with this task. So prints out all characters that are more frequent than the character A. From what? Standard input? I'm gonna go with standard input because you know, it's not specified. That are more frequent than character A. It's very simple. We just go with again int I for I equals 0, I is less than 256, I plus plus. If the number of occurrences of ith character is greater than the number of occurrences of A, then just print this character, right? puts I. Is that it? Prints out all characters that are more frequent than the character A. Strictly more frequent. Let's write something like that. A. You know, and then we get like 3 VWs, 3 the same number of E's and more Q's and more R's. Oh, we have we probably shouldn't do it like that. Oh, and you see the code blocks is now funny with me. Now that works. So again, the same test. Couple of A's, you know. I know what that's going to be. FGH appeared more than A's. So that's it. You know, in the stdin, because it's again not specified. Selects all lines that contain twice as many digits as A's. So, yeah. Select all lines again. So lines. We are back to lines. We define character line as 500 characters again. You know, doing the same thing. While f gets character line size of size of line -1. Line size of line, and then std input, and it's not equal new, which it will be equal when the end of the data is that selects all lines that contain twice as many digits as A's. So let's put some variables here. Integer A count the digit count. They are both 0 here. Okay. And what do we have to do? We have to count them, right? Select all lines that contain twice as many twice as many digits as A's, right? Okay. So we need basically this. This one. And of course, we get every character, and if the character str of I is digit, this character. If this character that we are currently on is digit, we increase the digit count. If it is A, we increase A count. Is that clear enough? What? Okay. Is digit, if this is A, we increase the A count, and then we have to print the line if the digit count is exactly 2 times A. if the line contains 2 times as many digits as A's, we print it out. Something is wrong, something's wrong. I is defined, string is undeclared. Of course, because we are looking for the line of the length of the line. And here too. And here too. Yeah. Oh, there's not enough parentheses. Yeah, different. So, something like that, not printed, but we have to have like 2 times as many digits as A's. It's displayed. Okay, maybe too much. 6. Oh, that wasn't enough. Yeah, that's exactly how much. So then no A's and just a 2. Nothing. Empty line will be printed because it contains exactly 2 times more digits as A's, right? Again, A and any different digits works as well. Works the same. That's it. And it ends on the end plate. So that's a fiddler. Okay, checks whether letters or digits are more frequent on the standard input. Checks whether letters or digits on the whole standard input. So we're back to the characters, right? So CHR while get car CHR equal to get car, put it in its own parentheses, is not equal, and while this little guy goes up here, because the counting is not global, not for everyone, for the whole thing. And now we do something like that. If the character is a digit, if is digit the character, we increase digit count. So it's simpler than the previous one. If is a letter, if is alpha, is the function for that. It checks whether the character is a letter. So A count, because I didn't want to change the name of the variable. So is digit is alpha, and then we simply check if digit count is greater than A count, then what wins? Digit wins. Digits win. You can't see it, but I can see it. I can type it. Else if A count is more frequent than digit count, then puts letters. I hate it because now I can't see it. Letters win. And then else puts it's a draw. And yeah, something like that. I expect that. I'm starting to make mistakes, and I hate mistakes. Okay, so those digits win. Now check, maybe letters will win. That will win one time. And then letters win. That's the last program. So you can see that writing simple functions can also spend you a lot of time, save you a lot of time, spend, because characters, number, string. We used it like one time, but it made our program much clearer. One function, very simple one, and it makes it whole bunch, really much clearer than it should be. Then string is numerical. We also used it like one time, but it's useful. You can save those functions somewhere. Maybe you will use them. Maybe you can save them in a module. Then this get most common character. It was used a couple of times as a code snippet, basically. And this is very useful method of writing programs. So yeah, this is the last one from the 1.3, and this video is getting too long. So okay, here we go. Bye.